Hello everyone, welcome to this video. So in this video we are going to look at the solution of the weekly coding contest problems. First of all, let us start with the first problem, that is time travel. So what does question say? Geek loves to do time travel. He has been given an array ARR of size n number of years where he wants to travel. He is currently living in the year A array of 0. So basically there are n years given in the form of an array, and Geek likes to do time traveling, and currently he is in the year array of 0. That is the first element. For traveling to past year he requires 2 units of time, and for traveling to future year he requires 1 unit of time, and if the year is same he requires 0 units of time. So what does that mean? For example, from a particular year, if I am going in a year which is in future, then for traveling in a future year it requires 1 unit of time. If from a particular year, if I am going to a year which is in past, it will require me 2 units of time, and if the year is same it will require 0 units of time. Find total units of time consumed if it travels linearly throughout the years in array. So the geek travels through the years from array of 0, array of 1, array of 2 and up to array of n minus 1. So we need to tell what will be the total time consumed. For example, initially the geek is here, then he goes here. Now he is going in the past year because 2022 is less than 24. So 2 units of time will be consumed. Then from 2022 to 2023 he is going in future, so 1 unit of time will be consumed. So 2 plus 1 is 3. Now here he is only in 1 year, he is not traveling, so 0 unit of times will be required. You don't need to read input or print anything. Your task is to complete the function time travel, which takes n, that is the total number of years, and array as input parameters, and returns the total units of time for completing the travel, and the constraints are given here. Now here if we think about solving this problem, then how can we solve it? Basically geek is going in different years with respect to the array elements, from array of 0 to array of n minus 1. So we can just linearly travel, and if the next year is greater, it means the geek is traveling in future, then we will increase 1 unit of time. If the next year, that is with respect to ith year, if array of I plus 1 is less, he is traveling in past, so we will increase 2 units of time, and if it is same we will not increase anything. Okay, so if we look at the implementation, so for I in range n minus 1, this means this will run a loop from I equals to 0 to n minus 2. Initially answer is 0. If array of I is less than array of I plus 1, means he is going in future, so 1 unit of time will be added. Else if array of I is greater than array of I plus 1, he is going in past, because array of I is greater than array of I plus 1. So he is going in past, because this year is greater than this year, then 2 units of time will be added. And if array of I is equals to array of I plus 1, it is the same year, so no time will be added. Okay, so this way we will compute the total time and finally return the answer. The time complexity would be big O of n, and auxiliary space would be constant. If we submit the code here, let's submit it. Okay, so we have solved this question successfully. I hope you have understood this solution completely. Now let's move on to the next question. So now let's look at the second problem, that is last ferry standing. First of all, let us start by understanding the question. Once upon a time in a magical forest, there were n fairies standing in a circle. Okay, each with a unique number from 1 to n. The number of fairies are from 1 to n. A mischievous sprite named Geek had a peculiar habit. Starting with fairy number 1, Geek would count k fairies clockwise, including the fairy where the Geek is standing on. Okay, so if he starts from 1, so 1 is also included, and he will count for k fairies. And remove the fairy they landed on, so he will remove the kth fairy. Okay, starting or not, I would not say exactly the kth fairy, but he will go to k fairies, and the last where he stops he will remove that and go to the next ferry, then start with the next ferry. I'll also show you with the help of example, it will become very clear. This continued until only one ferry remained. Who would be the last ferry standing, that we need to tell. For example, if n is 5 and k is 2, the last ferry standing will be 3. We'll understand this example. And n is 4 and k is 3, then the last ferry standing is 1. You don't need to read input or print anything. Your task is to complete the function last ferry standing, which takes two integers n and k as input parameters and returns an integer representing the number of the last ferry standing. And the constraints are given here. So now if we think about solving this problem, then basically see, there are n ferries standing in a circular queue. You can assume it like this. So 1, 2, 3, 4, 5. Starting from the first ferry, Geek will traverse k ferries, and he will remove the kth ferry and then repeat the same process from the next ferry onward. So let's say he starts from 1. Now k is 2. So he will stop on the kth ferry. So this is first and this is second. So he stops here. So he will remove it. So he removed this ferry. Now remaining is 1, 3, 5, 4. And since he removed 2, he will continue from 3. So this is the first, this is the second. Now again the count will start from 1 and this is the kth ferry. So this will be removed. Now the count will start from 1. So this is the first, this is the second. So this will be removed. Now only 2 are left. Okay, so when you remove it, they go out from the circle. So actually now the circle contains only 2 ferries. Okay, 3 and 5. Now you start from 3. This is 1, this is 2. So you remove it. So the last standing ferry is 3. So you return 3. That's the basic idea. Okay, so let me take one more example for better understanding. Let's say n equals to 10 and k equals to 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's say there are 10 ferries. You start with 1 and the fourth ferry will be removed. So first, second, third, fourth. So this will be removed. Now again count will start from 1 here. So 1, 2, 3, 4. This will be removed. Now 1, 2, 3, 4. This will be removed. 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 1, 2, 3, 4. This will be removed and your answer would be 5. Okay, so I hope you understood the solution and I hope I have not made any mistake here. So the answer is 5, but you got the approach, right? How we do. So what we will basically do here is we can take a vector or you can say a dynamic array in which we will remove the ferry which needs to be removed. So how will we do this? For example, let us take n equals to 10. So in our vector, we will first push the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, but their indexes will start from 0. So this indexes will be this. Okay, these are the values which I pushed inside the array, which are the ferry numbers, but these are the indexes, right? Now what I will do is I need to remove the kth ferry. Okay, now I'll first of all decrease k by 1. So k will become 3. Why I decreased it? You will come in a while. So what will happen now? I will start with this index. Okay, so initially my index will be 0 and I will always remove I plus k modulo size of this array. Okay, so size of the array is, let's say, s. I will always remove this ferry. So let's see. So first of all, I is 0, k is 3. So I plus 3 is 3. So I will go to this index and remove this ferry, fourth one, which is right, because when I started with 1, so 1, 2, 3, 4, I had to remove this ferry whose number was 4. Then I again had to move 4 steps, right, and then remove the 8th one. So here I'll remove the 4th one because it is I plus kth index. So my I will become what? 3rd index, and I will remove this. Now when I remove this element, because it's a dynamic vector, so this element will be removed. So the indexes will go further. Okay, so now this element will come at index 3, this will come at 4, this will come at 5, this will come at 6, this will come at 7, this will come at 8, and the array size will decrease by 1. Are you getting my point? That's why now doing only plus 3 will work. Otherwise actually we have to do plus 4 because we are moving 4 steps ahead every time. But because in dynamic array, when you remove an element, that elements get decreased, they removed from the array, and other elements indexes come one less. That's why now k equal to 3 will work. For example, now I is 3. So 3 plus 3, k value is 3 modulo size of the array. How many elements are there at present? 9. So 6 modulo 9 is 6. So now 6th index is what? This. What is the element at the 6th index? 8. It was here, but when we removed this element, it came here. So now we will remove it. So this element will be removed. 9 will come at 7th index and 10 will come at 8th index, and the array size will still decrease by 1. Okay, and we will keep repeating this process. So this loop will follow, and when the vector size will become 1, we will return the element which is there in the vector. Now let's look at its actual implementation. So if we look at the actual implementation, so initially I have decreased the value of k by 1. Okay, I have decreased the value of k by 1. Then I have started index with k. So I have not taken it 0 because I am increasing the index after erasing. If you increase it before, you need to start with index 0. But here I have started with index k. I have taken one vector in which I have pushed all the elements from I equals to 1 to n. Okay, which are the ferry numbers. Then until the vector size is more than 1, means until there is more than one ferry, erase the ferry which is at index position, and then index equal to index plus k modulo v dot size, whatever be the vector size, and this process will keep repeating. So we'll move in that respective loop, and ultimately only one element will be remaining when we will come out of the while loop, and that ferry would be the last remaining ferry, so we will return it from v of 0. Now let's submit this code. Okay, so we have solved this question successfully. Now let's move to the next question. So now let's look at the solution of the problem, that is collecting coins. What does question say? Geek has 2D grid which contains n coins. Okay, so there is a 2D grid which contains n coins. Geek also knows the position of all coins, as he has a 2D array coins where xi, yi denote the position of the ith coin. So there are n number of coins with the geek, and geek also knows the position of all the coins in this grid. Okay, in the 2D grid. Geek can move in only one direction, that is either right or left or up or down or diagonal. Okay, so you need to find out the maximum number of coins geek can collect. Geek can start moving from any point on the plane. So there is a 2D grid on which n coins are present, and starting from any cell, geek can move in any one direction. Okay, so either he can move towards right or left or up or down or diagonal. Okay, but in one directional only. So we need to tell what is the maximum number of coins which the geek can collect. Note diagonal movement refers to this. So from I to j, he can go to I plus 1 j plus 1, or I plus 1 j minus 1, or I minus 1 j plus 1, or I minus 1 j minus 1, means all four directions. The direction cannot be changed once geek started moving in a particular direction. That is, if he is going right from I comma j, then he can go only right only. Okay, so the direction cannot be changed. So here this is an example. The output is 4. I'll explain you the example in detail later. Here the output is 3. Again the output is 3. You don't need to read input or print anything. The task is to complete the function collecting coins, which takes n coins array as input parameters and return the count of maximum number of coins geek can collect, and the constraints are given here. So now if we think about solving this problem, then what basically this problem is trying to say is, let's say we are given a 2D grid. Okay, size of this grid is not given, but let's say we are given a 2D grid, and here randomly some coins are placed. Okay, in different total there are n coins, and here where they are placed is given to us in the form of an array. Okay, so we are given an array which contains n elements of the form xi, yi, which denotes the row number and column number of that element. Okay, so the position of the coins is given to us. Now geek can start moving from any cell. Okay, let's say he starts moving from this cell. So starting from any cell, geek can move in any one direction only, either right or left or up or down or diagonal in any one direction. Okay, so from a particular point, if geek starts moving right, he will move right only. From a particular point, if geek starts moving left, he will move left only. If he moves up, he will move up only. If he moves down, he will move down only, and similarly for diagonal. Okay, now we need to tell what is the maximum number of coins geek can collect. Now understand one thing. Let's say if I want to travel right, then I will start from the leftmost column. For example, let's say I want to travel right. So I'll not start from here. Then I'll collect only one coin. I'll start from here. So I'll collect all the 3 coins. Are you getting my point? Similarly, if I want to move up, I will start from here so that I can move in all the rows, right? So what I'm trying to say is, when we are moving right, we will move from the first column. When we are moving left, we will move from the last column, when so that complete all the columns can be traversed. While moving up, we will start from the last row. While moving down, we will start from the first row. Similarly for diagonal elements, for example, I want to cover this diagonal, so I'll start moving from here. So I'll cover all these 4 elements. I will not start moving from here, otherwise I will not cover this coin. Are you getting my point? So now my question boils down to maximum number of coins in any row or any column or any diagonal. Now diagonal can be along the main axis as well as the secondary axis. Okay, so diagonal can be like this also as well as like this also, because we can traverse diagonally in all the 8 directions, all the 4 directions, right? So the question boils down to what are the maximum number of coins in any one row or column or among any of the diagonals. So row and column, we know if 2 coins have the same row number, they are in the same row. right, irrespective of column number. Similarly, for two coins to be in the same column, what we can do, they need the same column number irrespective of their row number, right? But diagonally also there are some properties. Okay, so let me tell you. Let's say 1 2 3 4, 1 2 3 4. Let me talk about this diagonal. So what are the positions? One, first row second column, second row third column, this is third row fourth column. So here the value of row minus column is constant. Can you see it? Row minus column is -1, row minus column is -1, row minus column is -1. Similarly, check this. This is third row and first column, and this is fourth row and second column. Row minus column is 2. Here also row minus column is 2. So for all the main diagonals, the row minus column number value is same. Similarly, for all the secondary diagonals, row number plus column number will remain constant. For example, let me consider this one. Then the first element is first row third column, second is second row second column, and this one is third row first column. So here also the sum is 4, here also the sum is 4, here also the sum is 4. So if I just conclude, then two elements are in the same row if they have the same xi value, two elements are in the same column if they have the same yi value, two elements are in the same main diagonal if they have the same xi minus yi value, and two elements are in the same secondary diagonal if they have the same xi plus yi value. Okay, so what I can do is I can put all these elements in four lists. One, I will only put the row number. Another, I will only put the column number. Another, I will only put the row number plus column number, and another, I will only put the row number minus column number. Now for all the elements in which those values are same, they will be in the same row or same column or same main diagonal or same secondary diagonal. Okay, so how can I do it? See, let me take one row list. In this I will insert only the row number, that is 1 3 5 4 2 1. So here if I see, if I select any one row, the maximum number of coins I will be able to select is 2, that is this one and this one, because this is also first row first column, this is first row fourth column. Okay, now in the another list column I will insert only columns, that is 1 2 3 1 3 4. Now if I select a particular column, I will be able to select how many maximum coins? 2 coins. Either I select the first column or I select the third column. Okay, because this is first row first column, fourth row first column, and fifth row third column, and second row third column. Okay, so they are same. Now another is main diagonal. So for main diagonal I need to store the differences. Okay, so if I store I minus j, it is 0, this is 1, 5 minus 3 is 2, 4 minus 1 is 3, 2 minus 3 is plus 1, and sorry, 2 minus 3 is minus 1, and 1 minus 4 is minus 3. So if I select any of the main diagonals, then maximum I would, so if I start moving from a particular point in the bottom right direction in the diagonal, then the maximum number of coins I would be able to select is how much? Only 1, because all of them are present in different main diagonals. Okay, and if I talk about the secondary diagonal, I need to store their sum. Okay, so if I store sum, it will be 1 plus 1 2, 3 plus 2 5, 5 plus 3 8, 4 plus 1 5, 2 plus 3 5, and 1 plus 4 5. So if so the secondary diagonal whose row number plus column number is 5, in that secondary diagonal I have 4 coins. So I would select this diagonal. If I show you practically, here the row number and column number is going from 1 to 5. So let me create it. 1 2 3 4 5, 1 2 3 4 5. This is 1 comma 1, 3 comma 2, 5 comma 3, 4 comma 1, and 2 comma 3, and 1 comma 4. So can you see this? secondary diagonal where there are 4 coins. So I would start moving from here and in this direction, so I will be able to select 4 coins. Okay, so 4 is the maximum answer. So what I will basically do is I will make 4 lists. One is row, one is column, one is sum, and one is difference, indicating a rows, columns, and sum will denote the secondary diagonals, difference will denote the main diagonal elements. Out of them I'll sort them, and for each I will count the maximum occurring repeating element. Okay, and out of all of them, whichever will be the maximum element, that would be my answer. Now how can I find the maximum frequency of any element in an array? So suppose the array is not sorted. Let us say it is 1 3 2 3 3 1. So first of all I'll sort it, so it will become 1 1 2 3 3 3, right? And now I'll say for I equals to 0, I is less than n, I plus plus will not come here, j equals to I, and while I is less than n and array of I equals to array of j, I would say I plus plus, and answer equals to max of current answer and I minus j. Okay, and initially my answer variable will be 0. So once I have sorted the array, what will happen? Initially I will start with 0, j will be equal to I, so j will come here. Now while I is less than n and array of I is array of j, do I plus plus, so my I will come from here to here and from here to here. Now since this and this element is not same, it will break down and it will say answer equals to max of 0 comma I minus j. I minus j is 2. What does 2 denote? The count of ones. Okay, so my answer variable will become 2. Then in the next loop my j will come here and I will also come here. Then I will stop here because this and this is not same. Then answer will be equal to max of answer comma I minus j. I minus j is 1, so answer will remain 2 only. Then in the next loop my j will come here and my I, since these two elements and these two elements are same, will go out of the loop, and this will be j, this will be I, and answer will be equal to max of current answer value will be 2 and I minus j will be 3. So answer will store the value 3 because there are 3 3's in this. Okay, so in this way we can count the maximum occurring elements frequency using big O of n. This will be done in big O of n only, right? Why? Because there are two loops but every element is been traversed once only. Okay, from here you can see there are two loops but actually every element will be traversed once only. So now let's see its actual implementation. So if we look at the actual implementation, so this is the 2D vector of coins in which I have been given the position of n coins. I have taken answer variable as 0, count as 0, and I have taken 4 vectors which will be basically lists: row, column, sum, and difference. Then I have traversed the coins array, and in row I have pushed the row number, in column I have pushed the column number, in sum I have pushed the row number plus column number, which will denote the secondary diagonals. So two elements will have same row number plus column number if they are secondary, if they are in the same secondary diagonal, and difference will store the row number minus column number, which will be same if they are in the same main diagonal. Then I have sorted all the values. Then this is the code which I just showed you. So first of all I'll try to see the maximum number of elements in one row, so this loop will be for that. Okay, and it will store the maximum number of any coins in one row in my answer. Then this code will be maximum number of coins in any column, this will store it. And here in the here we are using the sum vector, so this will sum means the secondary diagonals, sum value will be same row number and column number if they are in the same secondary diagonal. So this will give the maximum value in any of the secondary diagonals, maximum number of coins, and this will give the maximum value in any of the primary diagonals. And finally I will return my answer variable. The time complexity here would be big O of n log n, because we are also sorting the array, and auxiliary space will be big O of n because we are storing the elements in row, column, sum, and difference. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you. So now let's look at the solution of the last problem, that is splitting edges. Okay, what does this question say? You are given an undirected tree of n nodes, each node having a value of I, either 1, 2 or 3. So there is a tree with n nodes, so it will obviously have n minus 1 edges, and the values associated with nodes are also given, and the values can be either 1 or 2 or 3. When you cut an edge, the tree gets split into two components, and this splitting is valid if both the components satisfy the below property. Now in a tree, whenever you remove an edge, we will also see with the example, the tree will get divided into two components. Now this splitting of after removing any edge is valid if the following condition is satisfied. What is the condition? Both the components must satisfy this property. What is the property? Let x be the product of all the nodes values in the component, then x should be divisible by 6. So when you remove an edge, two components will be formed. Now you take the product of all the nodes in this component, it should be divisible by 6, and the product of all the nodes in this component should also be divisible by 6. That is what it is said. In simple words, you are given an array value which contains the value of each node and an edges array which contains n minus 1 undirected edges of the tree. Find the number of valid splits of the given array. So how many valid splits of the array are possible, that is asked. Okay, of the tree. Okay, you need to split the tree into two components only, that is only one split is needed. Okay, so you, like, there may be multiple ways to do one split, you need to tell how many of them are valid. We will see this example, so you'll get an idea why it is 1. We will also see this example, so you'll get an idea why it's 3. You don't need to read input or print anything. The task is to complete the function splitting edges, which takes an integer n and an array edges and values as input parameters and returns the count of split geek can make. N is the number of nodes, edges is the edges 2D array in which the details about all the edges is given, and values is the array in which the node values are given, and the constraints are given here. So now if we think about solving this problem, then basically what it is given is, we have a tree with n number of nodes. Obviously it will have n minus 1 number of edges, and the values associated with these nodes are given. Okay, now we need to tell the number of valid splits. So what is a split and what is a valid split? A split is you remove any one edge from the tree. There are n minus 1 edges, and after that the tree gets divided into two components. It is called a split. What is a valid split? According to this question, when your tree gets divided into two components, if the product of the component is divisible by 6 for both components, then it is called a valid split. So we need to tell how many valid splits are there. So for example, if I look at this example, this is the value of the nodes and these are the edges. So 0 is connected with 1, so this is 0th number node, it is connected with 1. 0 is connected with 2, 1 is connected with 3, and 1 is connected with 4. What are the values? 3, 2, 2, 3, 1. 3, 2, 2, 3 and 1. Now there are four choices for us to split this or this or this or this. If I remove this edge, what will happen? Look here. If I remove this edge, my tree gets divided into two components, this and this. The product of this component is divisible by 6 because it is 3 into 2 into 3. It is divisible by 6, but this is not divisible by 6. So this is not a valid split. Now let's try to remove this. So here also this is first component, this is second component. This is divisible by 6 because it is 2 into 3 into 2 into 1, but this is not divisible by 6. So this is also not valid. Now let's try to remove this. So this component is not divisible by 6, so this is also not valid. Now let's look at the last option. Now you see here, this component has the product 3 into 2 which is divisible by 6, and this also has 3 into 2 into 1 which is divisible by 6. So this is a valid split. Okay, so this is the valid split, so only one is the valid split. There is only one valid split, so 1 is the answer. Now you look here, for any split, when can we say valid? See, here the node values given are what? For each node the values are 1, 2 and 3. So after removing an edge, if I get two tree components, and in this component if there is at least one node whose value is 2 and at least one node whose value is 3, then irrespective of other values this component will be divisible by 6, because 6 means 2 into 3. So 2 into 3 into whatever be the value, 1 or 2 or 3 or whatever, but there must be at least 1 2 and at least 1 3 in order for this component to be valid. Similarly, in this component there must be at least 1 2 and at least 1 3, so that the product of nodes will be divisible by 6. So what should be our target? We need to remove an edge such that in the other two components there is at least 1 2 and at least 1 3, so that both the components are divisible by 6. Now one way to do this could be, for each, after removing each edge, you run 2 DFS on both the components, count the number of 2's and 3's in one component, count the number of 2's and 3's in another component. If the count of 2 as well as 3 is greater than 0 for both the components, then it is a valid split because both the components are divisible by 6 and you return true. But in case that is not valid, then you remove the next edge. But here removing n-1 edges, and for each edge if you check in this way, after removing each edge, if you do a DFS, then the time complexity will be n square, because there are n-1 edges, and after removing each edge, if you do a DFS, the time complexity will be n square, which will take a lot of time. So you need to think of something more efficient. So what we can do here is, we will make any node a root node. For example, I am going to make node number 0. Okay, now when you remove an edge, then after you remove an edge, so here what I will do is, let's say I remove this edge. Okay, so what I will do is, when I remove this edge, there will be two components, and when I have defined root, these two components can be defined how? When I remove this edge, there will be a component which will be a subtree of this node. It will be a subtree of this node, and the other part would be the remaining part. Are you getting my point? For example, here when I say, if I remove the edge between 1 and 0, and 0 is the root node, so when I remove this edge, one part is the subtree having the root node as 1, so all the nodes are the descendants of 1, and another is the remaining part. Okay, it does not necessarily mean the parent of 1, it is the remaining part, because here there might be more nodes. Are you getting my point? Let's say 7 8 etc. So after defining a root node, when I remove an edge, I will remove an edge in such a way that I am removing an edge between this node and its parent. So the two components which I will get is, one the subtree starting with that node, and another is the remaining part. So if I can pre-calculate the number of nodes having values 2's and 3's in a subtree of any node, then my work is done. For example, if let's say there is a big tree structure and there is one node here and this is its parent, okay, and there is a lot of tree structure is there, okay. But if I have pre-calculated the number of 2's in its children and number of 3's in its children, and if I can get that in constant time, then my work will be done. How? When I remove this edge, I know the number of 2's and number of 3's in this subtree. I will also have a count of total number of 2's and total number of 3's. So let's say the count of 2's in its subtree is C2 and count of 3's in its subtree is C3. And the total 2's count is T2 and total 3's count is T3. So in the remaining portion, other than this subtree, what will be the count of 2's? It will be T2 minus C2. T2 is the total number of 2's, C2 is the number of 2's in its children, and the count of 3's in the remaining part would be what? T3 minus C3, because T3 is the total number of 3's and C3 is the number of 3's in this children. So T3 minus C3 will give me the number of 3's in the remaining part. Now if T2 is greater than 0, T3 is greater than 0, it means this component, sorry, not T2 and T3. If C2 is greater than 0 and C3 is greater than 0, it means number of 2's and number of 3's in this component are greater than 0. So this component is divisible by 6. And if T2 minus C2 is greater than 0 and T3 minus C3 is greater than 0, it means number of 2's and number of 3's in the remaining component are also more than 0. This component is also divisible by 6. So if all four of them are greater than 0, then I can say that my split is valid and I will increment my answer count. Okay. So in this way we will do. Now let's see how can we pre-calculate a number of 2's and number of 3's with the help of this example, and let's try to dry run it on this example. So first of all, let us draw the tree. So what is the tree? 0 has an edge with 1, 0 has an edge with 1, 0 has an edge with 2, 1 has an edge with 3, 1 has an edge with 4, then 4 has an edge with 6, and 2 has an edge with 5. So 2 has an edge with 5. Now you see, here the node values are 3 2 3 2 2 3 3 2. Okay, so if I write it here like this, 0 1 2 3 4 5 and 6. Okay, so the node values are what? It is 3 2 2 3 3 3 and 2, right? Now I want to calculate the number of 2's and number of 3's in the subtree of each node efficiently. So how can I do that? I will start a DFS from here. First of all, I'll increment the count of 2's and 3's uh, for all the nodes where the value is 2 or 3 itself. So let's say this is my C2 array, which will count the total number of 2's. So it will have 6 indexes: 0 1 2 3 4 5. 0 1 2 3 4 5 and 6, and this is my C3 array. Okay, just a second. 0 1 2 3 4 5 and 6. So what will this denote? C3 of 2 will denote the number of 3's in the subtree of 2. C2 of 4 will denote the number of 2's in the subtree of 4, and so on. Okay, so initially what I will do is I will make C3 of 0 as 1 because itself has value 3. Then C2 of 1 as 1 because it has value 2. Then C2 of 2 as 1 because it has value 2. C3 of 3 as 1, so because it has value 1, it has value 3. C3 of 4 as 1 because 4 also has value 3. 5 has value 3, so this will be 1, and 6 has value 2, so this will be 1. Others will be 0. Now I'll run a DFS, and during backtracking I will add the values of C2 and C3 of children in the parent node. Okay, so it will at the end give me the number of 2's and number of 3's in the whole subtree including the children. So when I do an DFS, from here I'll come here, from here I'll come here. Now there is no children, so I'll go back here, and for C2 I will add the C2 I will add the value of C5, and for C3 of 2 also I will add the value of C3 of 5. Okay, I mean, in the C2 array for second index I will add the value of fifth index, and for C3 array I will add the value of fifth index in the second index. So fifth index is 0, it will be added here, so it will remain 1 only. Fifth index is 1, it will be added here, so this will become 1. So this will become 1. Now from here I'll go here. So in 0th index I will add the value of second index. So in 0th index I will add the value of second index. So 1 will be added here. So this will become 1. And this 1 will be added here. Sorry, this will remain 1 only. This will be added here. So this will become 2. Now I will go here. And then from there I will go here. Now here there is nothing, no more children, so I'll backtrack. Now for the first index I'll add the value of third index. So third index value is 0, I will add here, it will remain the same. Here the third index value is 1, I will add here, it will become 1. Now I'll go from here to here and from here to here. Now there is no children, so I'll backtrack. For the fourth index I will add the value of sixth index. So fourth index is 0, it will be added at sixth index, it will remain 1 only. Here it is 1, it will be added here, so this will become 1. Now I will backtrack from here. So the value of fourth index will be added to first index. So 0 plus 1 will be 1, and 1 plus 1, this will become 2. So this will become 2. Now from here I'll go back to 0. So first index value will be added to 0 index. So 1 plus 1, this will become 2. Okay, and 2 plus 2, this will become 4. Okay, so my work is done. So what does this denote? In the subtree with root 0, the number of 2's are 2. It is correct. There are only there are 3 2's. So I have done some mistake here. Okay, but ideally what should be the array once you do the backtracking? So your C2 array should look something like this. Okay, I hope you got the point. I'll tell you. C2, this 0th index has how many 2's? 3 2's in the subtree. So this must become 3. Then for the first index it is 1 3 4 6. So 1, 3, 4 and 6. So how many 2's are there? 1 and 1, 2. So there are 2 2's. So this will become 2. Then for the third subtree, there is only 1 3. So there is no 2 and there is only 1 3. For the subtree with node 4, there is 1 2. So this will become 1. Okay. And for the subtree with 6, the number of 2's is 1, so this will remain 1 only. So 2's is done. For 2 it is how much? 2 and 5, so it is 2 and 3, so the answer would be 1. It is 1. And for 5 it is 0 because there is no 2 in the subtree of 5. Now if I look at C3, number of 3's in the subtree starting with index 0 is 4, so it is true. 1 2 3 4, yes. For subtree with 1 it is 2. 1 3 4 6, 1 3 4 and 6. There are two threes, okay, at 3 and 4. Then for 3 it is 1 because this is only one node. For 4 also it is 1 because 4 has value 3 and 6 has value 2. For 6 it has value 1, which should be actually 0 because in the subtree of 6 there is no 3, there is only 2. So this must be 0. In the subtree of 2 we have value 2 and 3, so it must be 1. It is 1. And in the subtree of 5 we have value 1 because there is 1 3. Okay. So first of all we'll add the values using the original values, and then using the DFS we'll backtrack and add the values of children. So you will get the value of C2 and C3. Now one after the other I'll try to remove an age with its parent. So I'll try to remove the age of 0 with its parent. There is no parent, so no need of removing. I'll try to remove an age of 1 with its parent, that is 0. I'll try to remove an age of 2 with its parent, 3 with its parent, 4 with its parent, 5 with its parent and 6 with its parent. So total there are n minus 1 cases, which is true. Now what are the total number of 2's? Total number of 2's are how much? 3. And total number of 3's are how much? 4. Now when I remove an age of 1 with its parent, that is 1 with 0, so the what I need to check? I need to check that C2 of 1 is greater than 0, C3 of 1 is greater than 0, T2 minus C2 of 1 is greater than 0, and T3 minus C3 of 1 is greater than 0. Because this will tell me the number of 2's and number of 3's in the subtree of node 1 in this subtree, and this will tell me the number of 2's and number of 3's in the remaining part. So C2 of 1 is how much? C2 of 1 is 2, which is greater than 0. C3 of 1 is 2, which is also greater than 0. Now T2, that is 3 minus 2 is 1, and this will be 4 minus 2 is 2. So all four of them are greater than 0, means it is a valid split. For example, if I remove this age, then 0, 2 and 5 have values what? 3, 2 and 3, which is divisible by 6. And 1, 3, 4, 6 has values what? 2, 3, 3, 2, which is also divisible by 6. So this is a valid split. In this way I'll calculate for all the n minus 1 ages using one for loop. Okay, and then return the number of valid splits. Now let's look at its actual implementation. So if there is a bit of doubt, it will also be cleared. So if we look at the actual implementation, then here first of all in the input we are given n, that's the number of nodes, values of the nodes and the ages. So first of all I have taken an adjacency list to create an adjacency list. This is a visited array which I will mark true whenever I will visit a node. This is C2 and C3 array to count the number of 2's and number of 3's in the subtree of the ith node. Then I have taken one answer variable which is initially 0. T2 is the total number of 2's and T3 is the total number of 3's. First of all, using all the ages, I have created the adjacency list. Then for all the n values, I have marked visited of I as false and C2 of I equal to C3 of I as zeros. Now for all the nodes, if value of I is 2, then I have incremented C2 of I plus plus and total count of 2. And if it is 3, then I have incremented the respective 3 value. Then I have called a DFS from making the 0th node as root node. You can make any node as root node. It will not make a difference. Okay. For example, here you can make node number 4 as the root node and check out. Then also you will get the same things. Okay. The same answer. So I have created 0 as the root node, adjacency list. Why defining a root node is important? Because we are summing up the child values of 2's and 3's. So when we remove an age, we need the count of 2's and 3's in a subtree and in the remaining part. So defining a root node or a parent becomes very much important. when you define a root node, with respect to that all the parents and children will be defined. Okay, but you can take any value. So I have called a DFS starting with the root node, that is 0, adjacency list, visited array, C2 array and C3 array. If we look at the DFS, first of all I'll mark the ith node as visited as true. Then for all the nodes which are adjacent to I, if they are not visited before, I visit them. After visiting them, I'll see a count of 2, that is the number of 2's in the subtree of I will add number of 2's in the subtree of x to it, because x is a children of I. So the number of 2's in the subtree of x will also be the number of 2's in the subtree of I. So I will add its value, and similarly for 3. Please remember, we need to call this after calling the DFS, because once you call the DFS, then only the number of 2's and 3's for x will be calculated, and then only you can add this value. So if you do it before this, it will give you wrong answer. So in this one DFS, I will calculate the number of 2's and 3's for each subtree. Now for I equals to 1 to n, I'll try to remove the age between the ith node and its parent. So I have started with I equal to 1, because I equals to 0 have no parent. Then if so the number of 2's and number of 3's in the subtree of I are C2 of I and C3 of I. So if the total count of 2 minus C2 of I is greater than 0, that is number of 2's in the remaining component, and number of 3's in the remaining component, and number of 2's in the subtree of I, and number of 3's in the subtree of I. If all of these are greater than 0, then this component is divisible by 6, and this component is also divisible by 6. So it is a valid split. So I will do answer plus plus and return the answer. What would be the time complexity? I am running a DFS, so it would be big O of n plus e, that is number of nodes plus number of edges, but number of edges is n minus 1, so it will be big O of number of nodes. The auxiliary space will also be big O of n, because we are taking some arrays of size n. Okay, now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood this solution completely. Thank you.